So can everybody see this?
Looks great.
Great, excellent. This is what is going to happen today. I mean, the talk itself is about morphology, and we're looking at a cross-linguistic context. I would like to talk about morphology a little bit in general, just so we're on the same page, and specifically about some aspects of morphology that are important for the studies that I will present to you. A little bit about morphological learning, and then I would like to dive into some data and show you what's been going on in these projects that I'm part of, and then perhaps a couple of takeaways, and then we can just talk about what happened. So I just want to start by, I guess, saying that the way that languages do morphology is in some ways similar. There's a limited range of options, but it's also strikingly different. And I do want to say one more thing. English, which is so widely spoken and it's the most studied language in the world, is essentially morphologically very boring. It's not a very eventful language in terms of morphology. And sometimes when we think about language learning, especially by adults, we kind of tend to forget that people might have to learn languages other than English, which present different morphological challenges. So as an example, here's a language that does morphology very differently from English. This is Chukchi, spoken in the part of Russia across from Alaska. If you were going to say something like, I'm leaving a good new metal spear, which is a thing that a Chukchi speaker has to say fairly often, how would you say this in Chukchi? You would say, and this would be one word. Now, within this word, we would see a very complex structure, essentially this many morphemes. And what you have is a pile of lexical material in the middle, sort of bookended by two inflectional morphemes, one of them saying the agent is first person singular, that's this one. And then this one says that the first person singular is doing something to the third person singular in the present, in the indicative. Okay, so this is how this works, and it's obviously very different from English, and not all of this material is allowed to stand alone, right? So it's actually bound material morphologically. And then something, I guess, less exotic, but still exotic to an American, Serbo-Croatian, a Slavic Indo-European language spoken in what we like to believe is still Europe. If you wanted to say something like this, which is, here's a daily meaning that you would want to express, several of them got drunk after drinking for a while, and there could hardly have been any more drinking. So this is the semantic content that you're trying to express. Well, in Serbo-Croatian, you could basically do this by saying, isko napiješ se, and that's it. One word and one reflexive pronoun will do the work of this bunch of words in English, essentially. There's a part that means to drink, but not to get drunk. Then when you add this red material, you're saying, well, to get drunk. And then this one letter here, which is a morpheme as well, means that it's imperfective, so it adds duration. We have some empty material here. This one means present, indicative, third person plural. And then this one will mean this one and this one and this one, sort of all over the place. And then the brown prefix actually means something like there was enough of it done and not a lot more was really possible. Okay? And so when you make a word like this, you're essentially, and when you say it, you're expressing all of that meaning in the English sentence, right? So different languages, different preferences for solutions. Why would one care about morphology? I think there are many different reasons why you would care. I mean, theoretically, it's very interesting because it's the meeting point for syntax, semantics, phonology, and the lexicon. Pretty much everything, not everything, but a lot of the things that we study in linguistics. In psycholinguistics and neurolinguistics, my two fields, it's been a very contentious topic. It's also been very dynamic. There's a lot of research on morphology in a lot of different strands. And there are actual trench wars happening between and among actually various schools of thought. It's interesting also if you're a bean counter and grouper of things because of the variation among languages. If you're fascinated by variation, you would want to look at morphology. In terms of learning and practical applications, morphological competence predicts a lot of learning outcomes, such as lexical knowledge or vocabulary size, right? And this is directly important for listening and reading comprehension. It predicts language proficiency. So when you look at what morphemes a baby is producing, you can infer what kinds of syntax the baby is producing as well. And finally, literacy. So just beyond mere comprehension, morphological knowledge is also important in word recognition in these lower level literacy processes. It's fascinating how it's acquired in a first language. So that's another reason to care. And from, I guess, the perspective of my program, Applied Linguistics, we care a lot about second language learning by adults. And what we find is that morphology, even in a language like English, where not a lot of it happens, is very difficult. And people struggle with it, even at fairly advanced levels, if they come from certain first language backgrounds. And then if you go, if you look at adults learning a language like Arabic, any variety, or Georgian, you see a disaster situation, essentially. So it's a fact that you can speak English without actually doing a lot of morphology, right? You can get by. So here are some sentences uttered by Wes, who is a famous case in second language acquisition. This is a Japanese gentleman who was extremely talkative. He lived in Hawaii. He had tons of English-speaking friends. He had a business. He was a highly functional individual. And the data come from Schmidt from 1983. So everybody who's ever been involved with SLA will have heard about Wes. But Wes did not really care much for grammar. And so, while he could have a perfectly competent adult life, and one would say happy life in Hawaii, I don't know that he would necessarily have gotten a good position if he hadn't been self-employed, right? With the government or with a company where he had to write a lot of memos. So being able to do morphology actually influences real people's real life outcomes, right? And this is why I care about it, apart from that theoretical and sort of psychological and neurological level. But can you get by without morphology in a language like Basque? This is a language people study for sure. I know a lot of people who had to study Basque in school. And here are some examples. Here is how you would say, I have, him, her, or it in Basque. You have your root, which means have. You have an absolutive suffix, which is third person singular and present. And you have an ergative suffix, which is first person singular and present. And you say tut. And this one word is actually an entire sentence, right? If you wanted to say, I had, him, her, or it, you would say nuen, okay? Where now the ergative suffix comes first and the absolutive suffix is not there because it's third person, so it's kind of understood. The root is still the same, fortunately, but you have this past tense ending. Then if you wanted to say something like, we would have him, her, or it, you would have to say genuke. Genuke now has the structure of an ergative suffix first and a hypothetical in this position. Now look at the root for have. It's gone from u to indu. In this case, when you say nindunan, you're expressing something like you, singular female, and familiar to me, not formal, had me, okay? You have to use this word instead. And when you're saying something like, you gave it to me, we have a sort of periphrastic construction here. We would say something like emandidasu, and the have form is right here. This means you gave it to me. So this is like a perfect tense, where now you can see that the have root has changed to I, And also you have this prefixal and suffixal material. So it's very, I don't know that it's possible to speak Basque without doing a high degree of morphology very accurately and to keep track of tons of different variables, right? Very different from English. Relevant for today's talk and for the studies that I would like to present, I will remind everybody of 4 ways that languages can do morphology. So we have what's traditionally been called as isolating languages or isolation, which is the tendency to have one word be one morpheme and be one morph at the same time. English has a very strong isolating tendency. And when we say something like, I see a black cat on the chair, this is essentially an isolating language where each word is just one morpheme. When you look at veo un gato negro en la silla, the Spanish version, you are actually getting words with more morphemes per word than just this. Of course, English is not completely like this. It has a tendency toward being analytical. Here's Mandarin, a Mandarin sentence that means he ate the meal at the factory. I have in the past pronounced this. I'm going to refrain from it just because I don't want to butcher the tones and I'm rushing. But what you can note here is that, again, it's this one morpheme, one morpheme, one morpheme, one morpheme. So we have he, at factory, inside, eat meal, perfective. And the very interesting thing is that the perfective marker, le, is not a suffix. It can actually move, but to come after the verb and before the, if you will, the complement of the verb, which is meal, right? So you can't do that to the English past tense suffix. We have agglutination as another mechanism. English likes to do agglutination in its native derivational morphology. This is a tendency to have one morpheme stand for one morph, and you just string them together, and each morpheme is very obviously what it is in the morphs that appear in the word. So for example, when we say unfriendliness in English, we are essentially agglutinating. We are simply stringing these things together, and you can tell the meaning and the identity of each part. They don't disappear in the word. They're not scrambled. The Turkish word, which means in my hands, ellerimde, is kind of like this as well. You have hand, plural, then a little bit of scrambling here because this means multiple things. It's first person singular and possessive, and then we have locative for the case. And this whole thing means in my hands. So again, no language is going to be perfectly agglutinating or agglutinative, but it's going to have strong tendencies like Turkish does. Fusion is a different system of sort of affixing things. And what happens here is that morphemes tend to be piled into single morphs and they're scrambled a little bit like an egg. So these are Catalan examples. This means I sing, this means we sing, and this one means I sang in the past. Canto, cantem, and canti. And what you can see is that all these meanings, first person and singular and present and indicative and active, they're all supposed to be inside this one sound, o. And there's no way for us to trace this first personness in for example, this. There's nothing similar. There's no shared phonological material among these three, right? So what we have to do is learn them as bundles of features, just memorize the whole suffix. We can't construct them from smaller bits. And here's some second person forms. Cantas, which means you sing. Canteo, which means you sing, plural. And cantado, which means you sang as a plural as well. So you can just see that there's no way to see some kind of structural relationship between these. Right. And then we have fusion in an even funner way, I guess, with discontinuous morphs. And these languages will often also have continuous morphs. And what happens with the discontinuous morphs is that you sort of take two combs and you interweave them together. You insert one morpheme into another. And these are often referred to as root and pattern languages. So these are Maltese examples. So the root k, t, b, which is unpronounceable, means to write. And you will insert these inflectional / derivational patterns, or you can insert them into these patterns to create forms like ktieb, which means book, or kotba, which means books. Something similar happens with the root ns, which means to forget. When you interweave it with these, or you add these continuous morphs here, you get forms like nessa, which means he forgot, and siet, which would mean she forgot, and sena, which would mean we forgot, right? Hebrew, one of the languages of our participants, works very much like this. So if we look at an adult learner, can we predict who will do well and who will do poorly? No. The short answer is we can't, but we know some things about this. With children, it's been known for a very long time that there seems to be a certain order for English speakers in terms of what grammatical or function morphemes they acquire in what order, and this does not correspond to what parents say. And this tells us that this is not mere frequency that drives the order of acquisition. There's something else going on. I guess based on this work, second language acquisition researchers for the longest time wanted to believe that there is a fixed order of acquisition for second language learners, invariant, regardless of first language background. This is really not the case. We have very strong evidence now that it's not the case. Unfortunately, I have to say that second language acquisition books still haven't kept up with this, and textbooks will still pronounce things like, there's a very strong tendency to acquire morphemes in this particular order. This comes from a publication by Krashen, and it's honestly, it's not the case. There is so much evidence that it is not, because your first language background matters a lot. So what are some factors that drive inflectional learning? Frequency is important. So frequency, the input matters, but it's clearly not the whole story. So what else? Other variables that have been tested and demonstrated to have some sort of influence are things like salience. So is it easy to notice the morpheme in the speech stream? And things that would cause it to be more noticeable would be things like it's a separate word, it is stressed as opposed to unstressed, and it's syllabic as opposed to subsyllabic, right? Another thing would be formal complexity. So morphemes with more allomorphs are harder to learn. Form meaning mapping is another thing. So morphemes in agglutinative and isolating languages tend to have one meaning, and they tend to stand on their own, if you will. That's easier to learn than something like Catalan, where those features are represented in single morphs as bundles. And there's evidence that, you know, Hungarian-speaking children are faster at acquiring their very complex morphology than, say, Italian-speaking children, who have to do a lot of that fusion or unpacking of the fusion, really. Transfer between languages, which can be facilitative, but it can also not be so good for you. So if your language has similar features to the language you're learning, you're studying, then that's good usually. If it doesn't have similar features, then that's not such a good thing for the learner. Something that people have been looking fairly recently, mostly in the field of neuroscience, is the variability of the input. So how many diverse exemplars are in the learning materials? How many different examples of the thing that you're trying to teach or learn? And then we have a range of individual differences, like various kinds of memory, procedural, declarative, working memory, phonological, short-term memory, general intelligence, and then a host of other things like motivation and anxiety and willingness to communicate, and many other things that are in these models of individual differences. I'm specifically interested in cognitive variables. One thing that we really don't know, and that my work is trying to start untangling, is how they interact to produce actual outcomes in learning situations. So I'm going to tell you about the first study. These are my wonderful lab members who participated in the first two studies that I will present. This is Daniel. This is Maren here. She's now doing a doctorate, but she was an undergrad at this time. This is Tiana and Masha. So you could think of us as the core team, and then our wonderful research assistants. There were more that I couldn't cram into this slide. This is Abigail, this is Rebecca, Leo, and Sangan. And we all work as the Language and Memory Lab in Flagstaff. So in this project, we created 3 artificial languages, and we taught them to people. We manipulated systematically the variables of salience, for-meaning mapping, input variability, and individual differences we just measured as a sort of background control measures. And the 3 languages where specifically salience and for-meaning mapping are sort of at different levels would be an isolating language where grammatical elements are salient because they're separate words. They're free morphemes, and the mapping is simple, so one element means one thing. We have the agglutinative language, where one element is also one thing, but the salience is lower because these grammatical elements are suffixes. And then we have a fusional language where grammatical elements are suffixes, and the mapping, for-meaning mapping is complex. We have these scrambled morphs. Our prediction was very clear. We thought that the language that had quote unquote no morphology would be the easiest. The second easiest should have been the agglutinative language, which has morphology but transparent, and then the fusional language, like for example Russian, which is a mess essentially in terms of what you have to learn. We had high and low input variability conditions. You had the exact same amount of practice in both conditions, but in one, people dealt with 32 different situations, and in the other 16 situations that were repeated twice as many times, essentially. So the diversity of what they were looking at was smaller. Excuse me. And then we measured their declarative memory capacity, procedural memory capacity, phonological short-term memory with 2 measures, and we gave them an intelligence test which had multiple components. A little bit about the languages, we call them Frasio. They all are mini languages with 8 nouns. We have 4 things that are containers: cup, glass, bowl, and container. We have 4 non-containers, little objects that sort of we place in or on the containers. And we have 1 verb, which is there is. We also have 2 number markers, singular, plural, and we have 2 spatial locators, and that's the whole language. So Frasio I is the isolating version of the language. So to express a meaning like this, there is a spoon inside a container, you would have to say asa, this is there is, asa igum maidus. This means singular, and this here means inessive, so it locates something inside an object. Spoken French works exactly like this, in that the number is assigned to a noun by the determiner. Vietnamese would be more like what this language would be in terms of isolation, or the degree of isolation, if it were a complete language. Frasio A, this is the agglutinative version. So this is meant to look something like Finnish, Hungarian, or Turkish, or Japanese, or Korean. And what it does is it has these transparent suffixes. The singular suffix is I, the inessive suffix is ma, and you can obviously stack them together. Asagumi dusima would describe this situation. Then we have the fusional language, which works a little bit like Serbo-Croatian or Spanish or Russian, in that it scrambles morphemes together into morphs. So this would be asagumi dusume. You can see that the singular element is not recognizable in the singular inessive suffix anymore. You just have to learn these as two separate things. Here's a summary of the grammars. We're focusing on how you say in a container. So in the isolating language, you say in one container, ma idus. If you say in containers, you say ma odus, in two containers. In the agglutinative language, you say dusima inside one container or dusoma inside two containers. So it's very methodical. You just vary this suffix, right? Or you vary the other suffix. In the fusional language, you can see that there's no similarity between the two suffixes. So inside one is ume, dusume. Inside two would be duseta. You just have to learn them and that's it. Tough bananas, right? We had 180 participants. It was an exciting experience to be positive about it. It was actually a nightmare because each participant had to be scheduled on 4 different days. There had to be spacing between the days. They had to spend hours in the lab. And of course, many of them canceled or didn't show up. So it lasted for a very long time. We had to ask for an extension of our grant. But it worked out. They were native English speakers coming from a range of majors. And they were essentially monolingual. Some of them had studied a second language, but were not proficient in the language. So they were at best lower intermediate or beginner. And the language was usually Spanish. There's a lot here. What this emphasizes is that a lot of things happened and there were 4 days. There were 2 to 5 days between sessions. Language training, the actual practicing of the grammar happened on days 2, 3, and 4. And what I want to underscore here is that we gave them 2 types of tests. There was what we call no transfer tests. We tested them on exactly the types of sentences and situations they had encountered. And something we call the transfer test, which is novel pictures, novel situations where they had to generalize any rules that they learned to material that they hadn't heard before. It was the same words, the same objects, but in novel configurations, essentially. So a little bit of a surprise factor. And these are some examples of these pictures that they had to learn how to understand sentences that described pictures like this. And the task on the tests was you saw 4 pictures. Some of them were close distractors and others were not so close distractors. And you would hear one sentence and you had to pick one of the 4 pictures as the match for the sentence that describes the situation, right? The 3 variables that I will focus on today would be accuracy. So how likely were they to get the answer right? Response times, how fast were they? And something we call the coefficient of variation, which is an indicator of how stable, how consistent your responses are. So not just fast, but are they equally fast every time? And this is taken to be an indicator of automaticity, which is a very desirable thing to have when you're learning a complex grammatical system. And these systems are not terribly complex as they are, but still, automaticity is desirable. So I'm only showing you results from day 4 from the transfer and no transfer tests for the 3 variables. And this is, I will just say, this is the high variability condition. So they had more diverse input. So the way this is organized, this is accuracy going from 0% down there to 100%. These are the tests of familiar situations, and these are the tests of new, unfamiliar situations. And the languages are agglutinative, fusional, and isolating. So the first thing you will notice is that they're less accurate for things that they've been practicing a lot. And this is because they got bored. that's the only explanation we have, because there is no difference in the difficulty. Actually, this is supposed to be more difficult. But once you ask them to generalize, to apply their knowledge to novel situations, well, they're doing pretty well overall. And this is on day 4. One thing that we can notice is that the fusional language, the one that's supposed to be the most difficult, is the most difficult. There's a huge spread in accuracy from people who are completely accurate to people who are barely getting anything right, even below chance. And the median here is lower, as you can see. And it's significantly lower from the agglutinative language, which is very accurate and fairly compact in variability. And then we have the isolating language, which is a little more variable, but it's looking like it's actually different as well. Now, this is the exact same, these are the same data, but grouped according to language. So agglutinative, fusional, and isolating. And we can see that for the fusional language, there is no difference between no transfer and transfer conditions, but a clear difference emerges for the other two. So this tells us that the fusional language is harder to generalize to novel situations, right? Some people do it fairly well, others are dismal at it. So don't learn Russian, I guess, is the, sorry, the takeaway. Okay, so in terms of response times, the only difference that we're seeing here is that on the test of familiar situations, the agglutinative language is slower than the fusional language. So it takes them a little bit more time to respond to these. In terms of the same data grouped by language, we see that within the fusional language, people are responding faster when the situations are familiar. This would probably tell us that it becomes a little bit difficult to apply this to novel situations. So it's consistent with the story from the previous slides. In terms of processing stability, again, this is very desirable because it may be indicative of automatic processing. We see one language is starting to break out, and that's the agglutinative language in the test of novel situations. A lower score means that the processing is more stable. And so what this means is that they're probably processing this more reliably than the other two languages. Looking sort of within the languages, but between the tests, there are no significant contrasts in terms of stability. So they're equally automatic, if you will, when they're dealing with familiar and unfamiliar situations. And in terms of those individual differences, I guess to my great disappointment, memory measures did not emerge as significant predictors of performance. And this goes against a lot of the things that you just expect from the literature, but we'll see what happens later. Crystallized verbal intelligence was a significant predictor of correct responses for the fusional language on both tests. So it looks like smarter people are getting the fusional language more accurately. If I may say smarter people, people who perform better on intelligence tests. And for the agglutinative language for novel situations only, which is supposed to be the more difficult test. Fluid intelligence, which is that G factor, which is sort of independent of situations, theoretically at least, is a significant predictor of processing stability for all three languages. So it looks like people who are faster processors are more automatic processors as well. That's what we're seeing here. So just a brief discussion of, I guess, what this might mean. In terms of ease of learning, it looks like the fusional language was the hardest. So a language, in practical terms, something like Spanish or Polish, would be the hardest type of language to learn. Arabic for sure for English speakers, based on morphology. Now English, Okay, actually, let me not say that now. In terms of how people responded to the fusional language, particularly to scenes that they hadn't practiced before, is that there was a lot of variability, I'll remind you, from very accurate to extremely inaccurate. Switching to scenes that were not familiar slowed people down, so their response times were longer. And for novel situations, processing stability also drops. It looks like they're whatever automaticity they might have gained, they lose now when they're shocked by scenes that they hadn't seen before for the fusional language. Now, something that we really didn't expect is that the agglutinative language is the easiest language to learn. So in a simplified way, what this means is go learn Hungarian, but it really doesn't, because Hungarian is much more complex than this mini language that we taught people. Now, English inflection is actually mildly fusional, so you would expect some kind of transfer to the fusional language, but the problem is that English inflectional morphology is extremely weak. It barely survives anymore. And so it doesn't seem to play a role in facilitating the learning of fusional morphology. However, as I mentioned before, English has a highly agglutinating tendency in its native derivational morphology, right? So it's not strongly agglutinating in the Greek and Latin and Norman French morphology that it borrowed, but it's strongly agglutinating in its Germanic morphology. And this could be transferring on some level. The agglutinative language is processed more slowly than the fusional one, and this is interesting because it seems to indicate that doing that decomposition, analyzing the word into 3 morphemes, takes a little bit of time, but it results in more accurate processing, right? Whereas with the fusional language, you only have 1 morph to deal with, but then what it means, heaven help you, you really don't know. And that's why your accuracy tends to be lower. And the isolating language, very interestingly, so the one that does things telegraphically, is not the easiest. And this was a revelation to me, because what it underscores, I think, is that morphology any brain would rather do morphology than syntax, it looks like, even though morphology can be terribly complex. But it looks like there's a cost for having to do syntax instead of morphology. But of course, this is a preliminary finding, so it's an inkling that I get from looking at these data. In terms of individual differences, if there are any trends, it looks like crystallized verbal intelligence is important for the fusional language on both tests, familiar and unfamiliar, and only for unfamiliar in the agglutinative. And what I think this tells us is that it just underscores that the fusional language is harder to process. Fluid intelligence is related to processing stability. This could be because these are early stages of learning, and we know that at very early stages of second language learning, people use their explicit resources, cognitive resources, and these are related to intelligence. So this could be one reason that this is showing up as relevant. It could also mean that people who are quote unquote more intelligent, whose G scores are higher, are better processors of information, which we know to be true, actually. The absence of a connection between declarative and, very disappointingly for me, procedural learning. We had a test of learning where they had to learn a sequence of muscle movements, and that typically correlates with syntactic performance for very, very strong brain-based reasons. This did not emerge here, and it's possible that it didn't happen because we needed more training over a longer period of time for this to become visible. All the studies of second language learning that have shown a connection between procedural learning and grammatical learning were essentially syntactic in nature. So I am going to keep studying this in the domain of morphology because I think it's really important. Okay, so what happens if the variability of really the number of pictures that you see, the number of different situations drops by 50%? You could liken this to a classroom with maybe fewer examples, but the same amount of practice. That's just a little bit more repetitive and drill-like. I just have to take a sip of water here. So anything that is in red is essentially a difference between the high and low variability conditions. So one thing that we see is essentially the same pattern for accuracy. The fusional language is harder than the agglutinative and the isolating languages. Exactly the same pattern. The one difference is that these scores, the scores for familiar items, are lower and the variability is much less, which I think just means that they were extra bored with all the repetition. Grouping this according to language, we see the same pattern as for high variability, which is wonderful because it's a replication. These are different participants doing the same study, but in a different condition. So what we see here is that the fusional language, again, is not emerging as significantly different between familiar and unfamiliar, but the other two are. This one kind of approaches significance right here. In terms of response times, again, it's a fairly similar pattern. The agglutinative and fusional languages, again, the agglutinative is slower because you're doing that extra work of putting things together or disassembling them, and the fusional language is faster but less accurate, and that's with familiar scenes only. In terms of response times within languages but between the tests, we actually see something different. So with low variability, only the fusional language was slower for novel situations. But here, all three languages are slower when you switch to unfamiliar stuff. What this means is that I guess they didn't get enough diverse practice to be able to generalize as easily to novel situations. In terms of processing stability, a fairly similar picture. The agglutinative language is more automatic than the fusional, but it's also emerging very interestingly that now it looks like the isolating language in terms of automaticity, the one where you have to do syntax, is more akin to the fusional language. There's a difference between agglutinative, and a very strong difference between the agglutinative and the isolating language too. So this only happens in the low variability condition. And looking within tests, we definitely see a different trend. Processing stability drops, not only for the, I mean, it actually didn't drop for any language in the high variability condition, but it drops for the morphologically complex languages, so that when you switch to novel situations, all of a sudden you're doing more explicit processing. You're sort of shocked into having to think again, whereas you were doing things. Sorry, no. I'm misinterpreting my own data here. It's the exact opposite. You are processing things more automatically, which is actually highly unexpected. I know why I got confused over this. I will explain shortly. So a drop in this coefficient of variation means more efficient processing, which is not what you're expecting. My explanation for this, part of the explanation would be that they got more practice on a narrower range of items, and perhaps they were better to extract and automatize the rules a little bit faster. Sorry about that. Now, with individual differences, we sort of see a marked difference in that they're becoming much more predictive of behavior, of behavioral outcomes than in the high variability condition. So we see that intelligence matters for a whole lot more here. Different facets of intelligence will be related to different types of performance in different languages, but the overall story is that intelligence is emerging as something more important when the variability is low. So smarter students are going to do better. Phonological short-term memory, which is sort of your ability to repeat sets of things that you heard earlier, becomes predictive of response times and processing stability in the agglutinative language, which is not surprising at all because the agglutinative language has that stringing along or stringing together of elements. And our test of phonological short-term memory was to repeat sets of numbers that were increasingly larger. So it actually makes perfect sense. And then declarative memory capacity, this was explicit learning ability that we measured through a word learning task, is predictive of response times, which probably tells a story that the processing overall is a little bit more deliberate in this low variability condition. And just a, I guess, brief discussion of the second part of the findings here. Essentially, we see the same pattern. The fusional language is the hardest, the agglutinative language is the easiest, and the isolating language is in the middle and surprisingly not the easiest language to learn. Some specific differences between high and low variability. Accuracy for familiar scenes drops, and this is probably because of boredom. Just lots of repetition of the same picture, same sentences. The difficulty of the fusional language when you have to switch to unfamiliar scenes just becomes even more pronounced. It leaps out. The response times sort of become shorter for familiar scenes, and the difference in response times between familiar and novel scenes seems to be amplified and more pronounced for all three languages. So the higher processing stability for the agglutinative language also is just starker in this condition. And it's obvious that it's more stably processed than than the other two languages, essentially. Processing stability for novel scenes becomes easier to achieve, and it might just be because less variable input leads to better extraction of rules in terms of achieving automatic processing, but not in terms of achieving accuracy, which is really interesting, or not completely. And these processing stability scores are sort of compacted. There's less variance in them. Overall, it looks like students are having to think more when the variability is lower. Okay, and this leaves me a little bit of time to talk to you about so this is a different project happening in the US and in Israel. It's an international collaboration. And apart from having a behavioral component, it's also a brain scanning project. So we're using functional magnetic resonance imaging to basically monitor blood flow in the brain as people are doing morphological learning. So these are the people involved. The three sort of principal investigators are here. This is Tali, and this is James. Tali works at Haifa in Israel, and James works at Vanderbilt in Nashville. This is Bracha Nir, who is also at the University of Haifa, and she's a linguist. So these are neurolinguists. You have a psycholinguist here. Bracha is a cognitive linguist. Brianna here is a neuroscientist. Upasana is also a neuroscientist. Marissa and Stav are also budding neuroscientists / speech language pathologists. We would like to thank the National Science Foundation as well as the Binational Science Foundation, the US-Israel sort of equivalent of the NSF, for the funding that they have provided us for this study. So here's what we're trying to do in this project. We're interested in a couple of different things, morphological type, but this time happening inside a language rather than across 3 languages. We're interested in transfer, and to this end, we have Israeli, Hebrew-speaking, and US English-speaking monolingual participants. We are looking at input variability, but we aren't yet because we have only collected some data in the high variability condition, and then COVID happened, which if you have to get people into a brain scanner is very complicated. So we've been delayed, essentially. We just have some data to show today. And we're also looking at a range of cognitive predictors. We haven't analyzed those data, so I can't really tell you anything about that today. Our participants are going to be 70 English speakers and 70 Hebrew speakers. We have so far collected more behavioral and fewer brain data from 7 English speakers and 23 Hebrew speakers. Very little scanning has happened, but I can show you something as a teaser, I guess. Our predictions are the following. So we actually think that morphologically complex words will be easier to learn than morphologically simple words, and they will be easier to generalize to novel, essentially to words that you haven't been trained on, but of course you have morphological structure to help you guess the meaning of these new words. We also are saying that they will be consolidated faster, and I will explain what I mean by that. So sort of set into your memory faster than morphologically simple words. In terms of similarity between the first language and the second language, we think that having a certain type of morphology in your first language will help you learn that type of morphology in the second language as well, which is why we're contrasting Hebrew and English speakers. How do we sort of recognize decomposition, morphological decomposition? Well, we saw from the previous study that longer response times can be one signature of that. But specifically, we're looking for blood flow in left inferior frontal regions of the brain. So specifically in this area here, this is Brodmann area 45. It's also called pars triangularis of Broca's area. Whenever you're doing some sort of decompositional task in language, syntax or morphology, also phonology or compositional semantics, you get blood flow in these areas here. And so seeing this for morphologically complex versus simple words would mean that the people are probably doing decomposition, and this is based on just everything that we know about compositional processing, not just our data. In terms of consolidation, so consolidation refers to a memory becoming better bound together, easier to access, and more stable. One signature of this is this shift, and this is according to complementary learning systems. This is a theory in cognitive psychology and cognitive neuroscience that essentially says that we have one fast learning system that is there to apprehend knowledge quickly when there's only one opportunity to learn. And then there is a slower system that takes a longer time to learn, but also has more stable, more trustworthy representations. And this fast learning system hinges critically on the hippocampus. And the hippocampus, we have 2 of those, is buried inside the temporal lobes. And I will show you later, it's kind of deep under the cortex. And it serves to bind together novel episodic memories. So if I told you, for example, that the Catalan word for a chair is cadira, you could learn this out of this one exposure. And this is your hippocampus binding the sound and the meaning of the word together as a kind of cognitive hub. But as memories get consolidated, lexical memories specifically, we see that the involvement of the hippocampus drops to a point where a memory doesn't have to go through that hub. It's bound into a sort of unified memory that, without the hippocampus having to do any work. And so if we saw less blood flow for later stages of learning, we would have some brain evidence of consolidation, essentially. Here's the language. We call this language Budronibi, and this is because of our last names, Booth, Dronjić, and Bitan. Oh, sorry, and Nir as well. This is Bracha Nir here. So, you know, very, I guess, not modest of us to do this, but that's the name of the language. So what happens here is that we are teaching people, we're not teaching them any grammar per se, other than morphology inside the words. And they have to learn words for certain semantically related concepts. So, for example, things related to fish. We have a fisherman, a fish market, fish tank, and the school of fish. Things related to cars, we have a driver, a mechanic shop, a car tire, and a traffic jam. Things related to planes, we have a pilot, an airport, aircraft carrier, and a squadron of planes. Now, I will just tell you, and I will kind of, I guess, stop there, that the creation of this language took 2.5 years. With the revisions that we made, with the criticism that we got, with the first NSF grant that we didn't get, we went through many, many different iterations of this until we were completely confident that as many things as could be right are right for our participants. 3 conditions here. We have a complex nonlinear condition. So this is like Hebrew or Maltese or Arabic, where a root that means fish is discontinuous, and you cast it into these different patterns that are also discontinuous to get words like gulbaki, golbeku, gilbok, and gelbik, meaning these things. Typically, languages that do this type of morphology also do these other things. So Hebrew, for example, has a lot of concatenative linear morphs as well. And we do that, for example, with car, where you have fald, this means car, and then you have these suffixes, faldine, faldapa, falduk, and faldom, mean these things. And then what all languages do is they will sometimes express related concepts with morphologically unrelated words. Like we say pilot and airport, or we can say thief and steal, right? So this is essentially a suppletive solution, a simple, there's no morphology here. These are one morpheme, essentially, for all our learners know. Okay, so the training here happens over 4 days with some breaks in between, and they go into the brain scanner on day 1 and day 4, and then they do behavioral stuff on all 4 days. The language training is sort of simple. You hear a word, you have to repeat the word back, and you have to select one of 4 translations, and then you get feedback which says correct or incorrect, and you do that over and over again. The testing is exactly the same, but no feedback. And the testing in the scanner, just because you really have to minimize movement and you have to minimize the types of cognitive events that happen in the scanner. The testing in the scanner is a little different. They hear a word and they say it back, and they also hear a word and they have to judge a translation that is presented to them. So they don't select among 4, they're just pressing 2 buttons, correct and incorrect, essentially. So in terms of overall learning, and these are just results for Hebrew speakers because we have more of them and we're more confident that what we're saying is true. Well, we see that they're improving essentially. Over time, they're getting more accurate in knowing these word meanings. And there is a significant difference between the morphologically complex and the morphologically simple. The morphologically complex words, although you're having to do more cognitive work, are easier, because in a sense, you're having to do less work at the same time. This is for familiar items. In terms of reaction times, they're basically dropping indiscriminately, so they're getting faster over time. Nothing fun is happening here other than they're getting faster. In terms of generalization, with an S, because Upasana put these together, for untrained items, so essentially words that you haven't been trained on that you now have to guess the meaning of, we can see that they're pretty good at the complex nonlinear and complex linear, so where there's morphological complexity, and they're significantly less accurate with the simple words because there's no way of guessing what those mean. In terms of reaction times, there's really no difference. There seems to be a trend emerging, and we will see this as we get more participants, for the simpler words to be slower. This is the reverse pattern of what we observed when they were processing sentences up there in the other study. Consolidation. So how do we measure consolidation? It's essentially how much better, if you are better, are you better at the second session compared to the first session? Excuse me. So for accuracy, so far, nobody's better at anything between the two sessions, but we are seeing a trend here for this confidence interval. Who knows if it will narrow, but it's going in this direction. So if anything becomes better consolidated, it'll actually be the linear stimuli for Hebrew speakers, but we don't know. It's too early to say. In terms of reaction times, nothing is happening. So they're responding to all of them equally between the first and second sessions. And finally, some pilot brain data. This is from one participant, so it's really very, don't trust anything that I say because we just have to, collect more data. But what we're seeing in this one participant across the sessions is we are seeing some activation here. Now, exactly where this will end up will depend on the subsequent participants. It might actually get a little broader because no two brains are exactly the same. But what we are seeing is that for morphologically complex, compared to simple words, more blood is sent to this area of the brain, to the inferior prefrontal cortex, where this decomposition and recomposition is supposed to happen, right? More blood usually means more activity, which you would typically interpret as, okay, something's happening. This tissue is doing work, right? Here, we're looking at the brain, at a section of the brain from below. And so this is actually the left hippocampus. The cortex, the temporal cortex is here. This is the temporal lobe. This here is the insula. This is the frontal cortex. So you see that the hippocampus is buried deep within. And exactly where we were expecting this, which is on the left side, we're seeing activation in all three conditions for the first compared to the second side. So there's more blood going to the left hippocampus at the first session. And then when they've had some time to sleep it off, because the consolidation of this type of memory happens overnight, less blood is actually going to this hippocampus later. And we are now at an hour, so I will wrap it up. I just wanted to sort of highlight some main findings and some main things that I touched on today. So first of all, I think we see clear evidence that morphological type matters in second language morphological learning. We also see that input variability is important and that under different conditions, ultimately, you might make different recommendations for actual instruction, but it's too early to do any of that by far. What we see is that lower variability seems to, on the one hand, I guess, bolster automaticity. At the same time, in some other conditions, it makes people rely on effortful processing more, which is the opposite of automaticity. This will be very difficult to untangle. And because it's contradictory, And we also see that the effective morphological type becomes more visible when the variability of the training is lower. We also see that lowered variability leads to more reliance on explicit resources. We see that morphological knowledge helps lexical learning, so structure makes words easier to learn. We have some preliminary but exciting evidence that decomposition and consolidation are happening early into the learning process based on that blood flow. And we seem to be finding evidence for, and this complementary learning systems theory is very well supported in various areas of cognitive science, but our findings definitely conform to this idea that we have these two systems that learn differently, and we need them both. In terms of future directions, longer training would be great to see what happens to procedural memory. Obviously, you would want to take this into natural languages so that it's more real. It will also be experimentally messier, unfortunately, and harder to control. In the brain data, we expect to see that the English speakers will not do as well as the Hebrew speakers on the non-linear morphology, because they have very little of it in English, only in some irregular verbs and some nouns that form plurals irregularly. So we expect to find a difference there. We don't know what precise concoction of factors will lead to adults being successful morphological learners. And this is particularly true when it comes to complex inflectional systems, so not English, and especially in languages that are highly fusional and that have a lot of morphology happening. So I don't know. If you're interested in this, stay tuned. And probably get some elixir that will help you to not die, because I think it'll take another couple of generations before we know more. And I'd sort of like to stop here. And I guess back to Katie or Danko.
Yeah, we're going to open the floor for questions. I think, Vedran, feel free to stop sharing your screen and we can go back to looking at each other. And you all have unmute power now. So we'll open it up to everyone who's here.
So I guess I can ask a question. Oh, sorry. Go ahead.
Oh, go ahead.
Okay, sorry. So who's Danko? Was that you?
That was me, but I think somebody else started their question, so I'm gonna.
Okay, and it was hard to tell who. So.
Well, it was me, but I'm happy to wait.
Okay. Well, you guys duke it out.
Okay, I'll go ahead then. It's a short one. Thanks, Nico. So thank you so much. This is really, really interesting, and not at all my field, which will be, I guess, become clear now in my question. So for the study where you looked at different languages with Daniel and the people here, could there be any kind of lexical transfer going on, so that, because it seemed that you had the same lexical items and then kind of different configurations of the one? Could it be that, in the second experiment, the learners had mastered that so that it would be easier for them or something like that, or would that not be relevant?
Right. It wouldn't, because what I failed to make very clear, I guess in the interest of time, was that so different people, this was a between participant design, so different people were taught the different languages. So if you learned the fusional, then you didn't study the other two. You didn't know they existed, essentially.
Oh, okay.
Right? And then they were kind of randomly assigned to these conditions as they arrived into the lab. So no, the only way where transfer could have happened, I guess, was because of the phonological structure of the words themselves. But we kind of tried to not make them sound similar to English words. So they were bez, con, puh, gum, sal, tif, zem, and dus. So I don't think that it was English helping them in any way. Yeah. I had this same question at Slurf actually, so I just didn't make it super clear that it was different people.
Okay, it's me now. So thank you for your very interesting speech. I wanted to ask about how do you feel about the interaction between lexical and inflectional morphology, because you might have a language that is in inflectional morphology more of one type, and in, I guess, much more languages are more agglutinative in lexical morphology. Then how these two types interact, and what do you think happens when they conflict in any kind of experimental or real life setting?
Yeah, that's a great question. I honestly don't know at this point. So one thing that we do know about derivational versus inflectional morphology is that they seem to be supported by different brain systems. And derivational morphology tends to be easier to learn. These things tend to be memorized. So words that are derivationally complex tend to be stored as one unit and also separately. So the brain sort of relies on both mechanisms. Whereas we have fairly strong evidence that there's a tendency for inflectional morphology for people to do more decomposition of it in online processing. However, even frequently used inflectional forms are stored as whole word units, and so it becomes it's essentially the degree to which the brain is doing this decomposition and recomposition. So with that said, how that will combine in an actual language where you know, the derivation and the inflection are not equally complex is an excellent question. With my work, I am nowhere near answering that. And what I would like to do before I retire is certainly start looking at languages where there's a lot of morphophonological complexity happening. So what I really want to know is how does an adult learner manage to master, for example, Serbo-Croatian roots, which mutate from form to form, from one derived form to another derived form. The pitch accent changes, the vowels can change, the consonants can change in the root. So the root is almost, sometimes it's unrecognizable, as you will well know, between forms. So eventually I would like to get there and sort of try to see what that does to the learner. But right now, you know, I'm creating these toy languages and just trying to understand what happens when you have in and on and singular and plural and fused or not fused, and that's it. So it's early days. But it's fascinating to think about, yeah, the things that you mentioned.
Thank you.
I have a question about the methodology that you used. So when you did your first study on the 3 different variants of the language, how was it that you taught these languages? Did you go in order of like syntax and morphology? Did you follow some specific route? And then a secondary part of that question is, how did the students react when they were learning a harder one versus an easier one regarding motivation?
So they were only exposed to one language, and so we couldn't compare the same person responding to, you know, one versus the other. Anecdotally, because we weren't studying motivation, most, you know, they were motivated first of all by money, because we were able to pay them a handsome sum for a student. And also a lot of them said, oh, this is so interesting, you know, but then we could see them get bored with the repetition of the same items. So how did the training work? On the first day, you came to the lab, you were consented, you answered some sort of biographical questions, And then they did a battery of cognitive tests. So short-term memory in 2 tests, a test of intelligence, a test of procedural learning, a test of declarative memory, and then we ended that with a session of memorizing the vocabulary. So they had to look at slides, and they would look at a picture and a word, and they had to say the word back. And then we tested them on that until they got it 100%, essentially. And then when they came back for the second session, they were also tested to the standard of 100%, so no mistakes on the meanings of words. And the training itself looked a little bit like this. You would first listen to sentences. So you would see a picture, for example, a container with 2 padlocks in it, and you would hear a sentence in the language you were learning that describes the situation. You then had to repeat the sentence. It was also presented visually, and then you had to retype the sentence as well. So the learning was implicit in that we weren't saying, oh, look, this suffix means this. We were just making them process the language and type the sentences and say the sentences back while looking at the picture and seeing the sentence written. And then there was another situation where they had to, they would hear a sentence and they had 4 pictures and they had to choose the correct picture that the sentence was describing. And that's also what the test was, essentially. So that the learning was, I guess it would be called implicit in second language acquisition research, in that no grammar rules were discussed. And this is not what I recommend people teach language like. You need to teach rules explicitly, we know that. So does that address your question?
Can I ask a follow-up question?
Yeah, please.
So if that is not how you recommend teaching a language, how come you taught the language this way?
We were very interested in procedural memory. And the existing studies that contrast declarative and procedural memory tend to do things in this sort of task-based, implicit type of environment. So either they're playing some kind of game or they're seeing pictures and describing pictures. So for comparability, because I was hoping to extend these findings about procedural and declarative memory into the morphological domain, which we've kind of partially succeeded in doing for declarative memory. It was important to keep the study fairly sort of within what the other studies were. However, we know that if we want adults to really learn grammatical rules, we need to instruct them. And so a further follow-up down the road would be to do this study, but to add an explicit instruction component and to watch them go through the roof, because they will be doing much better, of course.
Thank you.
Yeah, thank you for the question.
Okay, can I ask a question? This is far out of my field too. So the thing that you said that I'm now most curious about is, what kind of things did you get wrong for those 2.5 years that people critiqued about your language?
Oh, so, well, first of all, it was us. We were critiquing it very, very, very severely, in that we would make something, we came up with one version, and then we thought, oh, but there's a root in Hebrew that sounds like this, we mustn't have it because it's going to lead. So we had to select phonological parameters, for example, such that there are certain phonological structures in Hebrew roots that are allowed and that are not allowed. So we had to keep that in mind. We had to avoid any similarity to English words. It's actually very hard to find sets of meanings like fisherman, fish market, you know, enough of them, because we have, these lexicons are actually fairly large. Off the top of my head, I can't tell you, but it's a huge spreadsheet with trained and untrained items. So to keep everything consistent, fairly similar, fairly translatable to both languages, it was a nightmare. And this is not even, I'm not even starting to tell you the kinds of problems we had, because, for example, once we had created one version of the language, we piloted we piloted it in that we had Hebrew and English speakers listen to the words and tell us what they were hearing. So transcribe what you're hearing. And they were transcribing really different, like they would hear vozdepu or something like that. But the kinds of transcriptions that they came up with sometimes were nowhere near. Maybe there was one sound that was actually in the word. And because all of us are cognitive scientists, we sort of thought, how stupid have we been? Of course that this is going to happen, because if you don't have top-down, if you don't have pre-existing knowledge of a word, how you're going to perceive a certain phone actually is influenced by what you know. And so Hebrew voice onset times and English voice onset times are very different, and they will cause you to hear the same sound as either a voiceless or a voiced consonant. It was just, so it was back to the drawing board. We had to reevaluate the kind of accent that the language was recorded in. And then we sent it for the first round of reviews, and it got slaughtered in certain aspects. And so we had to then take that into account and make it even better. But it was this process that where at the end, essentially, we were sick of it. We didn't want to look at it anymore. So I don't know what we didn't change.
Thank you.